Hey guys, welcome back to my channel. So today we're going to do exam style questions for the topic prime factors, LCM, HCF. We're going to do both easy and tricky questions. And through these questions, you'll better understand how to tackle questions from this topic. We'll be doing questions from both H and HR. And these questions are also useful for foundation because we'll be doing easy questions as well. So let's start with these questions and develop better understanding about what prime numbers are, what is HCF, and what is LCM. So if you look at the first question, it says that A is 3 to the power of 5 times 5 times 7 to the power of 3. B is 2 to the power of 3 times 7 to the power of 4. We have to find the highest common factor of A and B. So highest common factor is basically the highest number. So first thing you need to know is what is a factor? Factor is basically the number that you multiply to get a multiple. So for example, if we're doing 2 times 3 equals to 6. Now 2 and 3 are factors of 6, and 6 is a multiple of 2, 3, and 6 because it comes in the times table. So this is the difference between a factor and a multiple. So when you talk about the highest common factor, what we will do is we will look at the numbers that are common between A and B first, and then we will see what is the common power of those numbers. So in our case, if we look at A and B, you can see that we have 3 common and we have 7 common. 5 and 2 are not common, so they're not going to come in the highest common factor. Now for 3, we can see that the highest common power is 1 because this is 3 to the power of 1, and that is 3 to the power of 5. So 3 to the power of 1 is smaller than 3 to the power of 5, then obviously 3 to the power of 1 is common, not 3 to the power of 5. So we write over here, for the highest common factor, we have 3 to the power of 1. And now we look at 7. For 7, we have 7 to the power of 3 in A and 7 to the power of 4 in B. Once again, 7 to the power of 3 is smaller than 7 to the power of 4. So obviously 7 to the power of 3 is common. Over here, we write 7 to the power of 3. Now they want the highest common factor, just as the highest common factor, they didn't specify that we have to write it as a product of prime numbers. So what we can do is we can multiply 7 to the power of 3 by 3, which is equal to 1029. If you want to leave it as it is, you can leave it as 3 times 7 to the power of 3 as well. Both way your answer would be correct. Now, in the second part, they're talking about the lowest common multiple of A and B. Now, like we talked about it before, multiple is the number that we get once we multiply the factors. So to figure out the multiple of A and B over here, what we'll do now is we will look at all of the numbers. So when I say we look at all of the numbers, basically what I mean is that we will have 2 as well, we will have 3 as well, 5 and 7. So when you look at 2, there's only one 2, and that has a power of 3. So in the multiple, we will have 2 to the power of 3 as it is. Whereas for 3, we have 3 in A and B. So now we look at the highest power. So highest power is 5. So we write 3 to the power of 5 for the lowest common multiple. And for 7, the highest power is 4. So we write 7 to the power of 4, and 5 comes as it is. So if we compare the highest common factor with the lowest common multiple, we can see that it's kind of like the opposite. In the highest common factor, we took the common numbers, whereas in lowest common multiple, we took all of the numbers. In the highest common factor, we took the smallest common power, whereas in the lowest common multiple, we're taking the highest power for each. So as you can see, 2 had the highest power of 3, so we took 2 to the power of 3. 3 had the highest power of 5, so we took 3 to the power of 5. 5 had the highest power of 1, so 5 came as it is. And 7 had the highest power of 4, so it came as 7 to the power of 4. So this is your lowest common multiple. So that's how you differentiate between HCF and LCM when you're solving questions with A and B given as product of their prime factors, or even like when they give 2 numbers and you try to find what their LCM or HCF is. Now in the second part, we again have A, B, And now we have C as well. So we have A, B, and C. Given that HCF of B and C is 2 to the power of 3 times 7. And the LCM of A and C is 2 to the power of 4 times 3 to the power of 5 times 5 squared times 7 to the power of 3. We have to find the value of B, Q, and R. So for the HCF of B and C, we look at the common numbers. So common numbers are 2 and 7. So over here, they already said that the HCF is 2 cubed times 7. So as we know, we look at the common numbers first, and then we look at the lowest common power. So for 7, let me just highlight this. It's 7 to the power of 4 and 7 to the power of R. Over here, they gave us 7, which means R is going to equal to 1 because you look at the lowest common power. So for R, it's going to be 1 because we cannot take 7 to the power of 4 because that's not common between both of them. They said HCF is 2 to the power of 3 times 7 to the power of 1. And 7 to the power of 4 is bigger than 7 to the power of 1, which means R is 1. So based on this, R equals to 1. Now we talk about P and Q. So if you look at the LCM of A and C, we've determined that this is 7. For the LCM of A and C, we said that we take all of the numbers and then we take their highest powers. So LCM of A and C. We have 2 to the power of 4, then we have 3 to the power of 5, then we have 5 squared, and then we have 7 cubed. Now if we compare the 7s, for 7 we have 7 to the power of 3 over, and we have 7 over here. Now obviously 7 to the power of 3 has a bigger power, so we took 7 cube over here. Now we look at the 5s. We have 5 over here and 5 to the power of q over here. Over here, they say 5 squared, which means q will be 2. Because like we said before, we take the highest power. So this over here, this 5 has power of 1, and this 5 has a power of 2. Because we took 5 squared over here. Then for 3, we have 3 to the power of 5. So we can see that A has 3 to the power of 5, so this comes as it is. Now moving on to 2. We don't have a 2 in A, but we do have a 2 in C, which is 2 to the power of 3. So that means P was 4. So as you can see, there was no calculation for this question. We just had to compare the powers based on the HCF and LCM values given to us and then figure out what P, Q, and R are going to be. So for you to be able to solve this question, you need to know what is the difference between HCF and LCM and how you can use that difference to figure out what the value of the powers are going to be. And the next question says that A equals to 2 to the power of n times 3 times 5 to the power of m. We have to write 8A as a product of powers of its prime factors. So A is 2 to the power of n times 3 times 5 to the power of m. So 8A is going to be 8 times the entire thing, which is basically representing A. So 2 to the power of n times 3 times 5 to the power of m. Now 8 we know can be rewritten as 2 cubed because it's 2 times 4. 4 is 2 times 2 times 2. So they make the index of 2 cubed. So now 2 cubed times 2 to the power of n times 3 times 5 to the power of n. They want the answer as a product of powers of its prime factors. So over here we can see that these two 2's represent the same base of 2 and 2 is a prime number. So whenever we have similar bases being multiplied, we add the powers, which is one of the rules of indices, which we will also discuss in the upcoming videos for this playlist. So we add the powers and write it as 2 to the power of 3 plus n, and everything else comes as it is. This is 8A as a product of powers of its prime factors. Then for the next question, they're asking us to find the lowest common multiple of 28 and 105. So for this, we're going to make a chart. And using this chart, we figure out what the lowest common multiple of 28 and 105 is. So for you to find the LCM using this chart, what you will do is you will pick a number which divides both the given numbers over here. So let's see if we can find a common number. So we have 28 and we have 105. We know 28 comes in the 7 times table, the 4 times table, the 2 times table, and the 14 times table, along with the 28 times table. 105 comes in the 5 times table, 3 times table, 7 times table, 15 times table, and the 35 times table, along with the 105 times table, obviously. So if we look at these numbers, we can see that the common number is 7. Both 28 and 105 come 7 times table. So when you divide 28 by 7, we get 4. And when you divide 105 by 7, what we get is 15. Now we know 4 and 15 don't come in the same times table, so we'll have to divide them separately by different numbers. So let's first make the 4 a 1. So 4 divided by 4 is 1. And we know 15 divided by 15 is going to be 1. So these numbers that we have written on the side over here, these are our numbers which we will multiply to get the lowest common multiple. So what we'll do is for the lowest common multiple, we will multiply 7, 4, and 15. So that's basically 28 times 15, which is equal to 420. So 420 is your lowest common multiple. So remember, for the lowest common multiple, you can make this chart where you first try to find a common number that divides both the given numbers. And if there is no common number, then you keep on dividing them separately till you reach 1, like we did over here. And then you multiply these numbers on the side, and that gives you the lowest common multiple. And the next question says that A equals to 2 times 3 to the power of 43, and B equals to 16 times 3 to the power of 37. We have to find the highest common factor of A and B. So this question is very similar to the first question that we did. They gave us A and B, and then they gave it as a product of the prime factors, and they asked us to find the HCF and LCM. Over here, they're asking us to just find the HCF in the first part. So for the HCF, if you remember, we take the common numbers. So over here, if we highlight the common numbers are 3. But there's a catch. Look at B, it's 16 times 3 to the power of 37. 16 is not written as a product of its prime factors. It's just written as it is. So we first need to convert the 16 as a product of its prime factors and then compare whether there's another common factor or not. So for this, we know 16 is 2 times 8. 8 is 4 times 2. 4 is 2 times 2. So we have 4 2's. So that means 16 can be written as 2 to the power of 4. So this is 3 to the power of 37 times 2 to the power of 4. So now if we compare the factors again, we can see that we have 2 common as well, because there's a 2 over here and here. Once you've identified the common numbers, then we look at the powers. We have to pick the lowest common power. So lowest common power over here for 2 is 1, because A is 2 to the power of 1, whereas for B it's 2 to the power of 4. So obviously the 1 power is common. And for 3, the power of 37 is common, because that's smaller than 43. So our HCF is going to be 2 times 3 to the power of 37. That is your answer. Now let's say they were asking us to find the LCM as well. So just for your practice, I'm going to show what the LCM would have been. So for the LCM, we said that we take all the numbers. So it's going to be 2 and 3. And for the powers, we'll take the highest powers. So for 2, the highest power is 4, and for 3, the highest power is 43. So this is your LCM. Now for part B, it says express the number A times B as a product of powers of its prime factors. So A is 2 times 3 to the power of 43. B is 2 to the power of 4 times 3 to the power of 37. So we have to express the number A times B as a product of powers of its prime factors. So A times B is going to be 2 times 3 to the power of 43 times 2 to the power of 4 times 3 to the power of 37. We'll combine the similar bases like we did in the previous questions. So it's going to be 2 to the power of 1 plus 4. So if we highlight this, these are our common bases. And then for the other one, these are the common bases. So we'll write 3 to the power of 43 plus 37. Once again, whenever similar bases are being multiplied, we add the powers. If the similar bases are being divided, we subtract the powers. We'll explore this rule more in the rules of indices video, which I'll be posting very soon. So it's going to be 2 to the power of 5 times 3 to the power of 43 plus 37, which is going to be 8. So this is your answer for A times B as a product of powers of its prime factors in its simplest form. In the next question, they're asking us to write 2,250 as a product of powers of its prime factors. Show your working clearly. So now, in this case, whenever they're asking us to split a number into a product of its prime factors, we draw this tree diagram. We were basically just splitting it down into prime numbers step by step. So you split 2,250 into its factors, basically. You can pick any factor. If you pick big factors, that speeds up your calculation. If you pick small factors, that takes a bit longer for you to simplify. But there's no restriction on the type of factors you can pick. You can pick any factors as long as you're able to solve it easily and save time. So we know that 2,250 can be split into 225 times 10. 10 is 5 times 2. So we know 5 and 2 are prime numbers, which means we cannot further break them down. So this stops over here. We cannot further, break these numbers down. For 225, we know it's divisible by 5. So that's going to be 225 divided by 5, which gives us 45. 45 is 9 times 5. 9 is 3 times 3. All of these numbers are prime numbers, so we cannot further break these down. So that means we can rewrite 2,250 as 2 times, we have 2 3s, so 3 square. We have 3 5, so 5 cube. It said as a product of powers of its prime factors. So first you write the prime factors, and then whatever the number of, and then based on how many times that specific prime factor is, and based on the number of times that specific prime factor is being repeated, you make that the power. So 2 existed once, so 2 to the power of 1 is for 2. 5 is occurring 3 times, so it's 5 cube. 3 is occurring 2 times, so it's 3 square. So this is how you write a number as a product of powers of its prime factors. Then for the next question, they gave us two numbers and asked us to find the highest common factor. So very similar to what we have done in the previous questions, and you must have noticed by now that the pattern of questions is pretty much the same. If you're able to understand like past the questions and at least do questions for a topic from 5 papers, you will have a good grasp on what the question is going to ask you for and how you're supposed to solve it. So find the highest common factor of 200 and 420. So what we can do is we can split the 200 like we did in the previous question, make a tree diagram. 200 is 20 and 10. Once again, you can take any set of factors. There is no restriction on that. 20 is 4 and 5. 4 is 2 and 2. 10 is 5 and 2. We know 2 and 5 are prime numbers, so we cannot further break these down. So these are our prime factors. Now, I'm not going to rewrite this right now, as like as a product of powers of its prime factors. I'm going to first break down 420 as well. And then we'll just highlight the common numbers to figure out what the highest common factor is. So 420 is 42 times 10. 42 is 6 times 7. 6 is 3 times 2. 10 is 5 times 2. 7 is a prime number, so we cannot break it down. 3 is a prime number. 2 is a prime number. And 5 is also a prime number. So now we'll highlight the ones that are common because we want to find the highest common factor. So we can see that we have 1, 5 common. We have 1, 2, 2 2s common. And that's it. We don't have anything else common. We don't have a 5, we don't have a 3 in 200. We don't have a 7 in, we don't have a 3 or a 7 in 200. So those numbers are not relevant for the highest common factor. So our highest common factor is 2 square times 5. You can write it as a product of prime numbers, or you can write it as an ordinary number, which is 20. Then for the next part, it's saying A equals to 2 cubed times 3 times 5 times 7 square. B equals to 2 times 3 square times 7. And C is 3 times 5 square times 11. We have to find the lowest common multiple of A, B, and C. Write your answer as a product of powers of prime factors. So in the first part, they asked us to find the highest common factor, but with different numbers. And in the second part, they asked us to find the lowest common multiple, where A, B, and C are given in index form. So what we will do now is, like we've discussed before, for the lowest common multiple, we take all of the numbers. So all of the numbers are 2, then we have a 3, then we have a 5, we have a 7, and we have an 11. Now we talk about the highest powers for each number. For 2, the highest power is 3. It's going to be 2 cubed. For 3, the highest power is 2. So it's going to be 3 square. For 5, the highest power is 2 again. So that's 5 square. For 7, the highest power is 2, 7 square. And 11 exists on its own, just once. So 11 comes as it is. So this is your lowest common multiple as a product of powers of prime factors. And with that, we're done with the questions for prime factors, LCM and HCF. If you have any questions or confusions about any of these, please leave a comment below and I'll try to help you out. And if you're someone who understood everything and liked the content that I shared, please leave a like and subscribe to this channel because I'll be sharing more videos similar to this for the series of topic questions for IGCSE Edexcel Maths A for higher. And through these videos, you'll be able to better understand how to tackle exam style questions in your school mock exams and for the actual exams.